Hey guys, we're going to talk about explicit equations and implicit equations right now. So, an explicit equation is an equation solved for a specific variable. So, let me make sure I got my pen on here. Okay. An equation solved for a specific, running out of room, so I'm just going to keep writing, variable. Okay. All right, let's see. All right, an example of an explicit equation could be any equation that is y equals 2. That's what we see the most often. Y equals to 2x plus 7. That's one example. You can have another example that's x equal to something. X equals to, let's say, the cube root of y minus 4. That's also solved for x. We might have something like y equals x squared plus 2x plus 1. Okay, so all those are examples of explicit equations. An implicit equation is an equation that is not solved for a specific variable. So an equation that is not solved for a variable. I promise I'm working on my handwriting. All right. An example of an equation that's not solved for a specific example could be an equation like x squared plus y squared equals 12. Later in the year, you'll learn that that's an equation of a circle, okay? So right now you just need to know it's an implicit equation because it has x and y on the same side. Another example may be y squared plus 9y equals -4. Another example could be x times y minus 3 equals 15. So you can see the difference. Explicit, the one variable equals something else. Implicit, you got more than one variable on the same side. Okay, so some examples. Write an equation explicitly, meaning variable on one side, in terms of y. So we basically want to solve each equation for y. Then to indicate whether the equation is a function. Again, in the last set of notes, we talked about what it means to be a function. So it either has to have all unique x's or it has to pass the vertical line test. Okay, so I'm going to blow this up a little bit, so bear with me just a second. All right, if I look at example 1, okay, then I'm going to see that I want to solve for y. And so I have to first move x to the other side. Since that's a positive x, I'm going to subtract x from both sides. Anytime I have an equation, I have to do the same thing on both sides. Okay? I like having my x's first, so I'm going to use commutative property to switch that and put negative x, and that's a positive 20. So this still says the same thing as this up here. I just switch the order, okay? Now I'm trying to solve for y. I still have a -4 there. Since that's multiplication, I have to divide everything by -4. Remember, it's an equation, so you got to do the same thing all the way across, okay? So if I do that, the -4 cancels. Y equals a negative divided by a negative is a positive. It's assumed to be a 1 right here. So since there's no number there, that's assumed to be a 1, okay? That's important because that is a 1/4 x. I think I changed the font size. That's okay. Let's see if I can get it back here. Let's see. All right, so two negatives make it positive. 1/4 times x is the same as 1/4 x. Then I have plus 20 divided by -4. Positive and a negative makes this negative, and that's going to be -5. Okay, now this is a slope. This is a linear equation. If you graph it and look at it, it's going to be a diagonal line with a positive slope and a y-intercept at -5. So if you're not sure what that looks like, graph it. But this is a function because it passes the vertical line test. Okay? All right. Number 2, we're supposed to solve each equation explicitly in terms of y. So we're trying to get y by itself. So again, I'm going to subtract x squared from both sides. So I'm left with y squared is equal to -x squared plus 25. Okay? And then we have to do the inverse operation, and since we have y squared, the inverse operation for something squared is the square root. Okay, so we have to take the square root of both sides. When we take the square root, we always have a plus or minus. Okay, so it's going to be a plus or minus -x squared plus 25. Now, be careful here. The square root does not cancel the square, and it doesn't turn the 25 into 5, okay? So when you get to here, you're finished. You can't go any further because that's a binomial. Those are joined together with a plus sign. And if it were a difference of squares, then you could factor that and work with the square root. But because it's not, that's as far as you can go. So we're done. So if you graph that, you can see that that does not pass the vertical line test because that's like basically a parabola reflected on the x-axis. So it's going to be a sideways parabola. So that is not a function. Okay. Let's move down to number 3. Number 3, we're trying to get y by itself. X is outside the parentheses, so we're going to add x first. So we're going to have y plus 1 squared is equal to x plus 3. And then again, squared, we have to do the square root. This is in parentheses, so it's all squared. So this time when we take the square root, we have to add plus or minus on this side. I'm running out of room. But the square root does cancel the squared term over here and leaves just y plus 1. And then that is equal to plus or minus the square root of x plus 3. And then last but not least, I'm going to subtract 1. Because I subtract 1 after the square root is there, the -1 goes outside the square root. Okay? So y equals plus or minus square root of x plus 3 minus 1. Okay? All right, number 4, moving right along. We've got to solve for y. So again, we're going to try to get the cube root of y by itself. So let's first subtract negative 1/2 x. And then I'm going to have negative cube root of y is equal to 7 minus 1/2 x. And then I have a negative cube root, so I've got to get rid of that negative. So I'm going to multiply the whole equation by negative 1. What happens when I do that? Every sign changes. So this one changes to a plus, the 7 changes to a negative, and the 1/2 changes to a plus. So why do we do that? We have to do that to isolate the cube root in order to solve for y. Okay, so now cube root. Well, a squared undoes a square root, so a cube root has to be cubed. Okay, so I'm going to cube both sides. The cube root cancels the cube, and y is equal to, make sure you don't forget your parentheses, y is equal to negative 7 plus 1/2 x, all in parentheses to the third power. Okay, now you may not know what a cube, something cubed, looks like right now, and again we'll study these graphs as we go. Right now you're just trying to solve, so I would graph that on my calculator and see if it passes the vertical line test, and you will see that that does. Okay, all right, let's skip down and see if there's any more that look interesting that we want to do. 5 and 6 look kind of similar. So actually, let's look at number 6, because you have 2 y's and you're trying to solve for y. So when you're solving for y and you have 2 different y values, you're going to treat that a little bit differently. So since I have y's in both of these expressions, I need to move the 1 to the other side. So we're going to have x times y minus 5y is equal to 2x plus 1. And then these both have a y in common. So hopefully you think of factor out the y, and you're left with x minus 5 is equal to 2x plus 1. Now, this is multiplication. The opposite of multiplication is division. So that looked harder than what it actually is, but hopefully having an example will be helpful, at least for all of you guys that are doing really well and watching the videos and taking notes. All right, you're going to graph this. You're going to see that that's a rational expression later in the year. Right now, you're just going to look at it, see that it passes the vertical line test, and say, yes, it is a function because it passes the vertical line test. All right, let's look at an explicit function. Okay, let's see how it's written in function notation. Okay, function notation. Okay, if you have an equation and we have y equals 3x squared minus 5, you can always write that as f of x. When it says f of x, 3x squared minus 5, it's the same equation. It's just written in function notation. This is read f of x. Okay, so if you want to evaluate for a function, it gives you f of x. That's your x value. This is just the name of the function, so you keep, that is the name of the function. You're going to take the negative 5. You're going to substitute it in. Everywhere there's an x. And then when you evaluate that, anything squared is positive. 2 negatives is also positive. and then you add those and you get 78. So